Great, we can keep going. We have a limited time. Here, I'm going to introduce 3JS. 3J is one of the light and popular 3D graphics, let's say, library of a library. I think it's not a sort of framework, but it's a library for the web browser. Yeah, it's really popular. And even, I mean, the potential of the 3J is become bigger and bigger, you know, because web is become, you know, much more bigger. Because 3J is really, you know, light and fast and WebGL wrapper for the web graphics, let's say. There's a lot of example. I encourage you guys to tour the site. And here's the, let's say, boilerplate code. Yeah. Same as the canvas, I create the, I select the div that we create here, right? And then there's a syntax we need to follow. Yeah. Otherwise, you can directly ask the developer. Yeah, I have no idea. I'm just implement according to their API. Basically, we create a scene, right? And then render it here, right? Correct. And then we append this renderer to this div. Yeah. Just think about like the step, explicit steps. Okay. And then we create a camera and controller, so we can control like this. Yeah. And then this is, let's say, minimum code, I think. We need a camera, we need a scene and a renderer. It makes sense, right? It makes a lot of sense. Yeah. And then this is the actual the geometry construction that you need to understand, because this is nothing special. It's gonna be just very similar to each other. It is not going to change a lot, I guess, because this is sort of the, you know, the convention of the using this library. Anyhow, so basically in 3JS everything's mesh. There's no concept like knobs or whatever, just mesh. Yeah. To be honest, graphics card doesn't understand vertices and connectivity. That's it. They have no idea what's going on in terms of curve or shapes. Yeah. So in order to create the mesh, we need two ingredients. One is geometry, which is sort of a mathematical object, let's say. Let's say it has like a bunch of vertices and then connectivity. That's it. And then material. Material is more about like how they look, just like style. Yeah. And then there's a lot of different types of material, but at least we know we need to create the mesh. In order to create the mesh, there's two different ingredients. One is the object, geometry, and material. Yeah. With geometry and material, we are able to create the mesh here. And then we need to push this mesh to the scene here. This is what I did. Nothing special. And then I'm just creating the looping, like a continuous loop, so that this rectangle is keep like oscillating along the z-axis. Actually, this is y-axis. It's a little bit different coordinate system anyhow. So play with this one. Maybe we can do like this, a little more faster. Yeah, just like that. Let me jump next example. Primitive. So it has primitive shape. I created this sort of exercise from this API. So this API. Sorry. This API, the cone geometry. So we can simply copy, not recommended, guys, just typing, yeah. And then we have cone here. We have, let's say, let me decompose a little bit. Okay, this is the geometry and material, and we have a mesh, right? The mesh has, now we know what, right? What's happening behind the scene. That position, meaning this is the property of mesh cone, right? So that we are able to access the override the value directly. If there's a function like this, right? There's some input value probably, or no input value maybe. So we can understand just by looking at the code what the developer wants to do, right? So these are some of a very primitive, let's say basic, let's say implementation of a primitive shape in 3D.js. And then custom mesh. So this is mesh. I mean, this is a little bit low level things, but even for Rhino or any other graphics, even the people in this meeting who are familiar with the Unity, even the Unity is exactly identical approach because Unity used OpenGL. Yeah, this WebGL, OpenGL, they're essentially same. So for the constructing the geometry, most important thing is that create the vertices, let's say vector, and then make them make connectivity for the vertices. Yeah. So here I create the geometry. As I said, in order to create the mesh, we need to create the geometry and material. For the geometry, what we know is geometry needs a set of vertices and connectivity. Right. So that I push this vector to the vertices. Right. And then we have a color. Right. And then this is the normal vector for surfaces. Anyhow. And then this is the connectivity, basically. Yeah. Which describe the face. You know what? What is this? This is actually index of the vertices that we push here. Yeah. 0, 1, 2, 3, 4, 5, 6, and 7. Yeah. This is actually indicating the index. You know what? C# or Python in Rhino, if you create your own sort of custom mesh, they have a similar concept. Yeah, there's a vertices and face. You can define like a quad surface or triangle surface, let's say the connectivity. So these are the face 3, let's say 3 triangle shape. There's also the quad shape in Rhino concept. I mean, just as I said, to learn something new, we need to take advantage of our the knowledge that we already familiar with. I think this is a good approach. Then we have a material, and then now we are able to make the mesh out of geometry material that we already cooked above. And then I'm making some looping of this geometry. And then while looping, I'm trying to scale, right? Based on this mathematical equation. Yeah, it's nothing special. The scale, yeah. And then I want to challenge you guys actually, because this is from an easy way of using API. For you guys, probably you guys can make some sort of special like a class to encapsulate and then to make a automatic process. Yeah, from the injecting JSON file or GeoJSON, and then it automatically, the class is automatically create the vertices and connectivity, and then push this mesh to the scene, and then we can render it. I mean, this is all about like a, let's say pipeline things. It's nothing special. And also I create a example here. In the second day of the workshop, I gave you guys like my sort of plugin, right? There's an A1, I couldn't remember, but there's a component to save the Rhino geometry as a JSON file. And then we can push this JSON to this environment to reconstruct the Rhino things. I draw this on the Rhino, and then just simply like convert Rhino object to the JSON, and then reconstruct the Rhino shapes in the 3D.js out of the JSON file here. So it has vertices, set of vertices, XYZ, 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 crazy, yeah, all the way down. We have, just forget about this color thing. Then we have face, right? 804 means we need to make connectivity. We want to make a connection among the index 804 over vertices. Yeah, this is pretty much about it. Nothing special. And then this is the just boilerplate to install like a scene renderer div, yeah, controller here. And then also you can append some lighting, yeah, because it has a shader, like some specular or shade on the screen. Anyhow, and then I create the geometry, right? Loop through all the JSON file and then push these vertices to this geometry. Yeah, I'm just repeat, same fashion. And then we have a face. And then I'm simply looping the face, and then I just assign some connectivity to that geometry. And then color. So to think about, the geometry has just number as a vertex or face or color. It's just some of like a mathematical object. It has nothing to do with other particular API or whatever, right? I just create like a Rembrandt material as a sort of default here. And then eventually I'm able to create a mesh out of this geometry and material, and then push it. And then we can basically migrate the geometry from Rhino environment to 3JS. Yeah, this is the example. And what else we have? Yeah, so previously in we saw, we create the mesh land, like a land out of the image in the grasshopper environment. When I talk about the image component, right? So we can implement exactly identical algorithm in that 3JS. But for the visualization, right? I mean, the mesh itself is set of data, right? For the visualization purpose, we need to understand 3JS. I'm just follow the fashion to create a mesh with the geometry and material. So here, let's say change the other example. 0, so compute, come on, we are busy. Okay, great. So we have a height map here. Then we can reflect height map. Yeah. And then nothing special. Just one thing looks new, the image. What it does is basically parse the image from the internet and then give us a let's say image class here. So image class, yeah, let's say object has a width and height, right? Yeah, we can X-ray the image, right? Because we know we did learn how to create the object class, so we can predict. And then based on the width and height, I'm trying to inspect the color value of individual pixel here. So let me zoom in a lot. Just think about in the Photoshop, we can zoom in all the way in, right? So one pixel is like, we can zoom in like that much big, right? Just like that. So each iteration, we want to visit individual pixel using double for loop here. Where are you? Yeah, here. And then this is the special function. I mean, as I said, just go to the API documentation. There's a lot of like pre-built, inbuilt useful functions there. So get image data, we can just simply give it X and Y, yeah, because image is basically 2D, right? And then we can access and then parse the result, the value, and then reflect for the mesh in terms of the Z axis, so that we can make some like the elevation of the land, just like this, yeah. And then nothing special, yeah. We have limited time, so I can jump here. So previously we talked about like a 2D, right? How to capture 2D space, right? So we have a 2D and then we discretize like a tessellate 2D space in a computable way, the computable like area, so that we can build the individual pixels. But now we can expand the 2D pixel along the Z-axis. We have a 3-dimensional pixel box cell, yeah, like a box. We call it box cell actually, yeah. So what I did is I actually import the Barney object, which is famous for the 3D graphics, and then I mean individually reach if there's a vertices, and then I want to create the box cell there. If there's not, I'm just want to skip it. So at the end of the day, we are able to get this like voxelized Barney here. So here we have a Barney. Do you want to see Barney? Okay, I want to see Barney here. Yeah, this is Barney actually. Several vertices, right? And all the way down here, several faces. Yeah, this is the what the OBJ file. This has a vertices and a connectivity. I'm just literally revisit, individually visit, and then construct geometry. Here, yeah. Here, and then I create some small bounding box using the triple loop. Yeah. Yeah, that's it. I encourage you guys to decompose my code and then play with. And this is the other example. As I said, the OBJ and STL is sort of a text file. It's not a binary file. So we can take advantage of this file. You know, STL is famous for the 3D printings. So meaning that it has like a set of the face and normal and vertices. So for those who are interested in what is the OBJ file, you can visit here. And then this is some of the syntax that we need to follow, like face, yeah, vertices. This is just a simple rule, how they construct, you know. And then we have the STL file here, same as but different fashion, right? So it makes sense, we just follow it, yeah. Just normal, loop, vertices, loop start and loop end. You just explicitly mention the vertices, meaning the position, and the connectivity, meaning surface, well, mesh, yeah. So, and also I give you guys an example. This is actually funny, you know. So using the OGN Loader, the 3Js give us a special, like a wrapper, let's say class, and they take care a lot of burden job in terms of network communication and promising and async problem, things like that. So after load function here, we can simply put this line of code, and then we can just directly dump this object to the scene. Yeah, I mean, there's a lot of example for API in the internet, so I'm just implementing. Yeah, nothing special. So for the additional material, we have here A-frame. You know what? My first impression of A-frame is what is this? Do you know why? Because it's really easy and straightforward. Yeah, so even it doesn't need like any other JavaScript or TypeScript things. Yeah, obviously they could support, but you know, this is all about it. We have a scene here, right? Open and close, and then we have a sky and plane, meaning green plane, and a cylinder and sphere. That's it. Not only that, but also it supports like a VR environment. I don't know. It's very easy and straightforward, right? So I mean, this kind of very high level library is there, so you guys can push your boundary, you know, try to learn new thing. Yeah. So A-frame starter is there. And also, as a software engineer at Esri, I did several optimizations. So this is one of my articles. This is a very technical article, how we optimize the rendering loop. So for those who are interested in the rendering, how we optimize the performance and pipelines, I just leave some my opinion here. So for example, like a picking shape, which is also very computational expense. While looking, we need to compute the picking. So for example, like we use the quadtree or off-screen rendering technique. I mean, there's a lot of computational jargon there. So anyhow, and also while looking, we have the event loop, as I said. You know, we learn something by mouse move and click event. Think about it. The rendering loops keep going. At the same time, we append additional tasks to the render. Yeah, obviously the computation expense become larger, right? So I mean, there's several techniques that I just you know, wanted to share with you guys. So particularly this technique applied for the story map that I developed, particularly for the graphics, which is one of the product in the Esri. Anyhow, yeah. Any other question?